So what are the topics for today? What is replication? What is Replica Set Tutorial refer to? Some references and yeah. Okay, what is replication mentioned? It refers to the process of, say, creating as well as managing duplicate or say redundant versions of a database. Okay, so we'll end up creating more than one copies of the same data. This is what replication refers to, and there are three aspects to it. First is creation, then managing duplicate versions of database. Not only that, the other aspect, the third aspect is configuring the replication. Okay, so how does replication help? What is the use of replication? The replication tends to provide certain redundancy, as a result of which it increases the availability of your data. Replication enables a replication to access your data in your database in a very available way. It ensures your data is available 24/7/365. Okay, so replication, like you see in this diagram, tends to provide a sense of redundancy, which will, showing this as increasing graph does seem to make sense. Okay, in the sense, the more the number of duplicate or redundant copies of data you have, the higher the availability of your database itself. That's what it refers to. Okay, so what essentially replication, how does it behave in practice? Okay, replication basically will tend to synchronize a given set of replicas, which are essentially redundant or copies of the same piece of data, so that changes made to one replica are reflected in all the other members of the replica set. Okay, this process itself is referred to as replication. Okay, syncing of data, synchronization of data among the other members of the replica set. This process itself is referred to as replication. So we have a set of replicas here. We have three replica set nodes. Okay, and when we tend to say synchronize them, it refers to the fact that all the three replica set nodes have the same data set. So essentially, change made in replica set node 1 will and should reflect in all the other replica set nodes. Okay, this change should reflect in each and every other replica set nodes. So how does replication help us? Replication enables users to work with their own local copy of database. That's one advantage. But of course, each local copy of database, whatever changes you make to it will have to be synchronized or replicated with various other replica set node members. Okay, just to ensure a certain level of synchronization, just to ensure each and every replica set node member has the same data set. What is the frequency with synchronization is maintained? What frequency is synchronization maintained? That's a question from Raymond. Okay, as soon as, see, it's obvious, any read operations that you do, since there is no change involved, okay, there is no point in synchronizing replica set nodes at that point in time, but only when you do a write operation, since there is a change in the state of the replica set node. Mostly, in all cases, write operations happen to primary node in a replica set and MongoDB, remember. So if you make a change to primary member of replica set node, what you tend to observe in there is the changes will be reflected via the oplog. This oplog will be consumed. This itself is a process of replication. The oplog will be consumed and the changes will then be committed onto the secondary members of the replica set nodes. What is the frequency of this happening? It depends on how frequently writes happen to the primary. There is no hard and fast rule saying after every 5 seconds or 10 seconds there is a polling which happens. No, I mean the polling will tend to happen continuously. The secondary nodes will continuously tend to poll the primary oplog. Yeah, Raymond has a top-up question on top. You mean once DB changes happen, those changes will be automatically synchronized among all of applications? Yes, that's exactly what I mean. Once the changes to the primary happen, that's what I mean. Once there are changes to the primary, those changes will be automatically synchronized among all other members of the same replica set. Okay. So as and when we tend to have additional copies of data, we can tend to dedicate each member of the replica set node to perform some individual activities. Say like one replica set member can be dedicated to disaster recovery, one of them specifically for reporting, one of them for backup. Okay, I mean when you tend to have entities usually for disaster recovery or reporting or backup, these usually don't tend to add up to the availability part, but these tend to add up to different aspects that you bring in when you introduce replication. Replication of course ensures that we have a highly available setup. On top of that, with replication you can also ensure disaster recovery, reporting as well as backup. Because if you tend to do say reporting and backup on the same node, on a single node, then it will obviously say, you cannot back up on the same node, it doesn't make any sense, right? Reporting, if you try to do reporting on the same node on which there are active sessions happening, then it's not advisable. The reason being it will try to put a lot of load on your system. Okay, so it's ideally suggested that you have separate replica set nodes which will tend to help in disaster recovery, reporting or backup. Moving ahead, so the primary database will tend to have multiple replica sets in here. Okay, so if you observe the primary database in here, for example, let us call it a test database, this will tend to have replica set 1. When we tend to say replica set 1, it's actually a collection of replica set nodes. Okay, this replica set 1 itself will contain say 3, 4 or multiple replica set nodes. Okay, or logically referred to as a shard, a collection of these replica set nodes which is called a replica set or a shard. Primary database itself will tend to contain multiple replica sets. Okay, how many replica sets? The number itself will depend on how much data you have, because the more the data, the more you need to shard and the more replica sets you have. Two replica sets with the number 5. Okay, therefore. So why do we need replication? Again, just a quick recap of the concepts. Essentially to keep your data safe, because we can have a subunit replica set node which can just back up data from the primary and which will help in disaster recovery. Okay. Point number 2, and in fact this should be the point number 1. This is the single most important point that we refer to when we say replication. It is high availability. The application can access data 24/7, because if the primary goes down, there are secondaries which will be bumped up as primary, and you can access data from the secondary. Going ahead with the next concepts. What about read scaling? As we know, in MongoDB, if the primary goes down, if you have in the replica set, according to the configuration, the secondary will be bumped up as a primary. One of them will tend to be elected as a primary. Okay. Now, in between of this election, during this election time frame, okay, as you know, there will be a policy paralysis. Okay, coming back to the MongoDB world, there will be a process, there will be a period where there can be no reads or writes etc. So the architect at MongoDB said, we can never tell an application or an end user that during this re-election you cannot access your data. That would not result in a highly available system. So just to overcome this issue, they said we will end up enabling, or we can configure reads from secondaries as well. So the more the number of secondaries you have, which have the same replicated or redundant data copies as the primary, okay, your read scalability increases. How does it happen? Say for example, if you have one primary and one secondary, and say one arbitrary node, we'll come out and see what an arbitrary node is. An arbitrary node is one which does not have any data. It just tends to elect the replica set nodes. Okay, when the primary goes down. Okay, so if your replica set node has, for example, say one primary, two secondaries, and one arbiter. Okay, okay, we'll put it this way: one primary, one secondary, and one arbiter. Total 3 nodes. Okay, so in such a situation, if you want to do a read and your primary is down, then the reads will obviously go to the secondary. Assume your secondary is not up as a primary. So, what if your secondary also goes down? This would not be such a highly available situation. It's available, but it's not highly available. So, if you want to prevent such kind of outages, you can add more and more secondaries to make your system highly available. On top of that, say if for example there are 5 clients accessing a single secondary, that will put a lot of load on your secondary itself. So in order to prevent that, you can have as many secondaries as possible, and the more the number of clients that are trying to connect your secondary, the load will be evenly distributed across the multiple secondaries that you have. So if you have 10 secondaries and 10 clients, each of the clients will end up talking to the individual secondaries itself. Okay, that's how it works. It's also referred to as read scaling in MongoDB. We tend to see in a short while what is write scaling. Okay, so no downtime for maintenance. This refers to the fact that you need not bring down your database for regular maintenance activities like say backups or index or creating indexes, rebuilding indexes, compaction, all of that. There is no downtime at all because there are separate replica set nodes which are assigned one of these activities. Okay. Disaster recovery, as we all know, if a primary hard disk crashes or if data gets corrupted for some reason, then you can always tell to say I have configured my replica set in such a way that the secondary, which has eventually consistent data, will tend to be bumped up as primary. So I have not lost my data forever. It is still there in some other node. And importantly, replica set is transparent to an application. So let us just get some more clarity on how a replica set is transferred into an application. Okay. When we tend to say a replica set is transparent to an application, we refer to the fact that if there is any read or write operation happening, of course the writes are always channeled or streamlined to the primary itself. With respect to a read operation, it will first try and go and hit the primary. If the primary is down, it will go and hit the secondaries as well. In this way, there is a consistent pattern that is being followed here as to where the writes have to go, where the reads have to go, and all this is abstracted to an application. It just has to talk to a Mongo sharding server. Okay, the Mongo sharding server in turn will redirect it to the given replica set. Okay, and within the given replica set, the write will go to the primary. The reads will also go to the primary if the primary is down, and if a new primary is not yet been erected, it will go to the secondary if secondary is configured to be read enabled. Okay, so it's essentially very transparent to the application. The application need not have to do anything different. If there is a failover, if the primary goes down, any of that, no, it's very transparent. It's very consistent. Just to make a few things clear, replica set and sharding are one and the same. Sorry, a replica set and a shard are one and the same. It is just a group of MongoDB instances that host the same piece of data. Okay, so in this diagram that is seen here, it is a replica set or a shard, and the green one represents a MongoDB server which is primary, and the red ones represent the MongoDB servers which are secondaries. Okay, so one MongoDB, which is the primary, the green one, will tend to receive all the write operations. All the other instances, that is the one in reds, are secondaries. Usually the primaries tend to accept all write operations from the clients. Okay, not usually. The primary, only the primary tend to accept the write operation from clients, and replica set will tend to have one and only one primary. Okay, remember guys, there are other NoSQL databases in the market which will tend to say will tend to have multiple primaries, but no, in MongoDB unfortunately we tend to have a single primary. Okay, replica sets tend to provide strict consistency. Of course, I mean, with respect to primary it is strict consistency. If you think about the secondaries, it is eventually consistent. There is one question from Satman. These replicas will be on different server, however, who sets or decides how many replicas? Okay, these are the features of replication. Replica set is a cluster of n number of replica set nodes, one primary and multiple secondaries. Okay, in this case, any node can be primary node. There is again a caveat for this. We'll tend to see in the next 5 to 10 minutes why we say only not any node can be primary, only some nodes can become primary during election. All write operations will tend to go to primary. This is of course this should be written in bold and underlined. All write operations go to primary. Okay, automatic failover. There is nothing manual that you will have to do saying, okay, the primary has gone down, I will have to bump up the secondary to primary. You need not do it manually. All this is automatic. The failover that happens is automatic. Now, there is an automatic recovery process as well, which goes hand in hand with the failover. Okay, and there is a consensus for election of primary. Like I mentioned, if a primary goes down, there will be election that is triggered, and there will be consensus among multiple secondary nodes that are up, and they in turn will choose or elect a secondary to be bumped up as a primary. All this happens automatically. So it's a typical use case as to how read-write operations work in MongoDB and how they are replicated, how they are synchronized. You have multiple client applications that are talking to the primary database itself with the read-write operations. Just like I mentioned, all write operations happen on the primary. Okay. So just not to be confused what is happening in here. This, when we say background, the green icon should not be called primary database. It should be called primary replica set node. Okay, and all the read-write operations from the clients tend to happen to the primary replica set node itself. Okay, and when once the write operations happen to the primary replica set node, they are in turn replicated or synchronized with the multiple replica set nodes that we see here. Okay, there is some typo with this diagram which says replica set 1, 2, 3 and all. That is slightly confusing. The reason being, it tends to give an impression that the replica set specifically, I mean, it tends to write to different replica sets. That's not the right thing. The data from the primary will be replicated or synchronized with the replica set node members that belong to the same replica set. Okay. So okay. Now this is how replication and election works in MongoDB. So you tend to have a primary replica set node. Okay, representing it with the keyword primary database is incorrect. I want to get it corrected. And there is another replica set 1. There is another replica set node, the one that you see in white. Okay, that is a secondary for the moment. And there is another node in the red that you see called arbitrary. Okay, so all of these three, the primary, the secondary in white, and the another secondary in red, the arbitrary, all these three belong to the same replica set. Okay, all these three belong to the same replica set. They are nodes within the same replica set. So now when any write tends to happen, obviously the replication will be from the primary to the secondaries. Okay, that is one point. But there is a thin line in here. You know what? An arbiter is a type of node which does not hold any data. Okay, it's a kind of node which does not hold any data. So if it does not hold any data, there is no need for replication. Okay, this is a general concept that's being conveyed. That's why you see an R one called replication here. But if it's an arbiter kind of node, arbiter is also secondary node, there will be no replication. There will be no synchronization. So what is the use of an arbiter? An arbiter is a secondary node which just triggers selections, which just votes as to which secondary has to be bumped up to a primary. It does not hold any data. Okay, that's what it means. Now, first of all, how is the election triggered? An election is triggered because each and every node in the replica set will tend to monitor all the other nodes in the replica set and try to determine what is the status, whether it's up or down. So, I mean, as long as the arbiter keeps on listening to multiple replica set nodes, the primary or secondaries, and it determines, okay, primary is fine, primary is up, so everything is fine, nothing to worry. So, but in a situation where the primary goes down, the arbiter tends to understand that, okay, I have not got a heartbeat signal from the primary replica set node from the past, say, 5 seconds. Okay, then the arbiter tends to say that, okay, now I have to trigger elections, a new primary has to be elected. So the replica set 1 node that you try to see here, which is a secondary, that is the only other node, okay, that is the only other node which has data. So that has to be bound up, that is bound up to become a primary. Who votes in favor of the replica set 1? Of course, I mean, the primary is down, it cannot vote. The arbiter is down, which votes for the replica set node 1, replica set 1, which to be bound up as a primary. Remember, an arbiter can never ever become a primary. It can never be bound up to a primary. Why? Because it does not hold any data at all. Okay. So the communication between these entities happens through a heartbeat kind of thing. Now arbiter recognizes primary is down, or it also recognizes that another secondary replica set 1 is up. Hence, it declares that the replica set 1 MongoDB has to be bound up to a primary. Is that clear, guys? Some concepts associated with replication with respect to, say, replica set primary, replica set secondary members, how they were, priority 0 replica set members, hidden replica set members, replica set arbiter as well. So typical replica set deployment architecture looks like this. A 3-member replica set will tend to provide the minimum recommended architecture for the replica set. Okay. Typical deployment architecture will include one primary, one secondary, and one arbiter. Okay. Now, a replica set with 4 or more members, of course, it tends to provide greater redundancy and can support greater distribution of RAID operations. That is very true. And dedicated functionality as well. You can have dedicated functionality for each of the nodes for, say, backup or reporting kind of purposes, or even disaster recovery. Okay. What about replica set high availability? Okay, as I think yeah, 3-member replica set means 2 replica set nodes and 1 primary. Yes. I think we need to do a quick time check here. It's 9:15. I have this entire setup of sharding and replica set up and running on my machine. But it will take me at least 1 hour to go through this. Okay. So what I'll do is I'll just keep the setup as it is, and the first 1 hour tomorrow, since what we have for tomorrow is mostly MapReduce aggregation pipeline, that can be covered within 2 hours. I'm pretty sure about that. It will not even take 2 hours. But replica set, this entire replica set and sharding setup, along with Mongo monitoring service, will let us squeeze it within 1 hour of the first class tomorrow. Okay, I know. I mean, this is pretty much a stretch session. This is the longest session that we have in this MongoDB class. So what we'll do is we'll go ahead and get some conceptual information with respect to sharding as well now as part of today's class, and then we'll have this entire Mongo monitoring service as well as this entire sharding setup and replica set setup working together in synchronization. We'll have a look at them tomorrow. Does that sound okay? Okay, so okay, let us, yeah, we'll take a 5 minutes break, but let's just get done with this replica set availability. So as we all know, the main aim behind replica set itself is to have high availability. The higher the number of replica set nodes we have, the higher the availability will gain. We also how elections work within replica set, and of course we can set the read preference as well. Read preference is usually set on secondaries, so we can achieve better read performance through having higher availability or having higher number of nodes in a replica set. Okay, of course, the primary is configured for reads and writes. Secondaries are by default not configured for reads. We can explicitly configure them for reads as well. What about replica processes? Replica set top log. We all know how it works. Primary, once some data is written to the primary, the same delta information goes into the oplog of the primary. Oplog of the primary is consumed by the secondary and then committed onto the secondary local databases. And replica set data synchronization, of course, data is synchronized among all nodes, all the secondaries except if it is an arbitrary, which does not hold any data. Before synchronization, it tends to check whether the heartbeat or if the other replica set node is responding, and if the primary is responding, yes, consume data from its oplog and synchronize. What about master slave replication, which comes into picture only when you have 12 or more number of nodes? Can do some more fundamental operations, have higher availability, and basically come up with a configuration for the same for extremely high availability kind of use cases, which is pretty uncommon. So typical replica set deployment will tend to include the following: configure and deploy a replica set, okay, with one primary and multiple secondaries. Okay, you might end up removing members from replica set. This is what you can do at the runtime. You can add members to the replica set at runtime. You can also convert a standalone MongoDB server to a replica set as well within runtime. All these operations you can do.